Hello and welcome. My name is Osama Shukri, and this is the Build Scalable Applications using Docker and Kubernetes course. In the previous lab, you finalized the first microservice which serves the back-end REST API for the Fibonacci application. In this lab, you will create the other microservice which hosts the front-end website, hereby completing the two-tier Fibonacci application. Let's get started. You can find a PDF file with the full list of the commands you will run under the resources attached to this lab. Please download this PDF now and keep it handy to help you with typing the commands for this lab. Let's refresh a couple of things about the front end. The login.php script authenticates the user that attempts to log into the application. It does so by comparing the passphrase that the user typed to the value stored in the passphrase environment variable. Check lines 5 to 12. We will use a Kubernetes secret later in this lab to pass the value of the environment variable. The invoke.php script invokes the backend Fibonacci REST API. Please pay attention to line 5 where it expects the backend's endpoint at this URL. Remember that we created a cluster IP service that exposes the backend at this endpoint. We will define the front-end passphrase using a Kubernetes secret. A Kubernetes secret is an object that contains a small amount of sensitive data, such as a password. Using a secret allows you to avoid including confidential data in your application code. Secrets are similar to config maps, but are specifically intended to hold confidential data. A secret can be used to set an environment variable for a container, which is exactly what we want to do here. Check the contents of the file passphrase secret.yaml. The file is simple. It defines a Kubernetes secret that has one field with its value initialized to a placeholder. Launch your terminal and make sure you are at the Fibonacci sample/k8 directory. Run the following command to create the secret. Let's use the describe command to see what Kubernetes can print on the terminal for a secret. Please note that the value of the passphrase field is not shown on the output. We will use Portainer to fill in an actual value for the secret. Please note that we must set a value for the secret before creating the front-end deployment. This is necessary for the new value of the secret to propagate to the environment variable in the deployment. This is a limitation in Kubernetes. If a container already consumes a secret in an environment variable, a secret update will not be seen by the container unless it is restarted. Check this link in the resources attached to this lab for more information. Let's use Portainer to set the value for the secret. Launch Portainer using this link. Log in using your username and password. Click on the Kubernetes environment. Navigate to Config Maps and Secrets. Here is the passphrase secret. Click on it. And then let's fill in a value for the passphrase. Click Update Secret to save the changes. That's it. We have securely and easily set the value for the secret from the web browser. Let's check the Kubernetes resources for the front end. Check the file frontendresources.yaml. The file includes a deployment with one replica for the PHP front end and a NodePort service. Let's take a closer look at each of them. Deployment Fibonacci front-end deployment is defined in lines 1 to 30. Note the following properties of the deployment. We have one replica of the pod. The pod has the labels app equals Fibonacci and tier equals front end. The container in the pod is based on image Oshokri/Fibonacci front end, which containerizes the PHP front end for the Fibonacci application. You can keep it like that, or if you wish, you can replace the image with your own image that you created earlier in this course. The container defines environment variable pass_phrase, which gets its value from the secret passphrase secret. Now we look at the service. Check the definition of service Fibonacci front-end NPS in lines 32 to 44. Note the following properties of the service. Service type is NodePort. This type exposes the pods on a port on the host machine of the Kubernetes node. It allows us to access the front end from a browser on the host machine. The node port is 399, so this is the port we can use in the browser on the host machine to access the front end. We have the concept of labels and selectors here again. The selector of the service matches the labels in the pod template of the deployment app equals Fibonacci and tier equals front end. This way, the service knows the front end pod or pods it needs to expose. Go back to your terminal. We will create the front end deployment now. Let me reiterate that before this, you must have set the value of the secret importainer in an earlier step. Run the following command to create the front-end deployment and service. Wait a minute, then list the pods in the cluster. There are 5 back-end pods for the REST API and 1 front-end pod for the PHP website. We are ready to test the end-to-end application. Launch the front-end website at this link. Log into the Fibonacci application with the passphrase. Let's figure the Fibonacci of 44. The request was served by version 4.0 of the REST API server. Check if the persistent volume in the backend is still working. Open the log file on the host machine. The log entry for the Fibonacci of 44 is there. By completing the front end, our application is complete. Let's do a final progress check. In this lab, you created a deployment for the front end, which created a replica set with one replica, meaning one pod. The front end pod can reach the back end layer via its cluster IP service. The front end keeps the end user's passphrase in a secret. A NodePort service exposes the front end layer, thereby allowing the end user to reach the front end website from a browser on the Kubernetes host machine. Browse through the web UI of Portainer and check the Kubernetes resources that we created for the Fibonacci application. We have a lot of stuff there that together makes up the full application. For the back-end REST API server, we have a deployment, a NodePort service, a cluster IP service, a persistent volume and persistent volume claim, and a config map for the log file. For the front-end PHP website, we have a secret, a deployment, and a NodePort service. And we have Portainer to manage it all right in our web browser. That's it for this lab. Thank you, and see you in the next lecture.